Today we're going to be doing 7.4 notes. This is vertex versus standard versus intercept form. So the first thing it wants you to do is actually list out the generic forms of each of these quadratic equations. So vertex form is the one that we emphasized in the last lesson, and it's y equals a times x minus h squared plus k. Standard form is y equals ax squared plus bx plus c. Intercept form is the only one that's not on your formula sheet, and that's y equals a x minus p x minus q. So we have this next situation. It says you're ordering a quilt for a family member. The length of the squares is reduced by 3. Then you add a little piece of fabric at the end that is 4 square meters. So we have a square. And it says the length of the square is reduced by 3. So we have x minus 3. Now, because it's a square, both sides of this would be x minus 3. So to find the area of that piece of fabric would be x minus 3 squared, because it's x minus 3 times x minus 3. It says, and then you add a little piece of fabric at the end that is 4 square meters. So we're adding a little bit at the end that's 4 square meters. Put a y equals in front to make it an equation. So now the next part says describe the shifts that have happened to this equation. So based on that equation, we know that it's in vertex form, and the vertex is represented by hk. So in this case, the vertex, so remember when it says x minus h, so we have an x minus 3, that means your h value is 3, and then plus k, and we have a plus 4, so our k value is 4. So the other things happening with this, based on the shifts, is that it's going right 3 and up 4 when you compare it to the parent function. So at this point, we can almost graph it. We still need to figure out our a value. So our a value is that implied one that's in front of your set of parentheses. So that means when we graph that a value, we're going to go to the right and to the left 1 and go up 1. Okay, and that's from the vertex, just the same as we did in 7.3. So at this point, we're going to our graph. We know we have a vertex of 3, 4, and then our a value is 1. So we go 1 to the right of the vertex and up 1, and left to the of the vertex and up 1 to represent those that a value. So now we can draw our parabola. So when we move on, it says, now let's look at this equation. What form is it? Based on the top, this is in standard form. So now it says, let's convert it to vertex form using x equals negative b over 2a. So remember, this gives you the x coordinate for your vertex, which is the same thing as h. So we have x equals negative b. So we forgot to label our parts. So in this, we have y equals ax squared plus bx plus c. So because a is touching the x squared, there's that implied 1, so a is 1. B is touching just the singular x, so b is negative 6. And then c is at the end, is your constant, so it's that 9. So when we plug this into that formula for finding the x coordinate of your vertex, we have negative b is negative 6 over 2 times a is 1. So a negative times a negative makes a positive 6. 2 times 1 is 2. So your x value is 3. So now we take that 3 and we plug it back into the original equation in order to solve for the y value. So we have y equals, and remember, every time I do this, everywhere there's an x, I put a set of parentheses, so I make sure I cover everything. So we know that the x value is 3. So everywhere there is an x, we put a 3. And at this point, you can either plug it into a calculator or solve it step by step. 3 squared is 9. Negative 6 times 3 is negative 18 plus 9. So the y value equals 0. So the first thing we need to do is actually put it into vertex form. So don't forget that step. Go back to the instructions if you forget. So we found the vertex. The vertex is 3, 0. So now we plug it into our formula. So we have, I'm going to do an erase and replace to show all the parts of it. Nope. So the a value was 1. We don't need a multiplier of 1 up at the front. Our our h value is 3, so we can erase that and put the 3. And then our k value is 0, so we actually don't need that at all. So our equation ends up in vertex form as y equals x minus 3 squared. So when we graph this, vertex is at 3, 0. So we go to our x-axis and put a dot at 3. The a value is 1, so that means to the right of the vertex we go up 1. To the left of the vertex we go up 1. And then you can draw your line, your parabola from there. If you wanted to make this perfect and find more points on the line, you could use the table feature on your calculator. Recognizing the vertex and how A is applied to the graph is probably some of the most important aspects of graphing these. Okay, so on to the back. So it says convert this into vertex form. So start off with labeling your A and your B at least. So we know that A is 1 because that's what's in front of the x squared. Your B is 4 because that's what's touching just the x. And your C is your constant of 2. So if we're going to plug this into the formula for finding the x coordinate, x equals negative B over 2A. So negative 4 divided by 2 is negative 2. So now we take that and we plug it back into our equation, and we're left with y equals x squared plus 4x plus 2. The x value is negative 2. So again, you can use the calculator or you can work it out by hand. So we have y equals negative 2 squared is positive 4. 4 times negative 2 is negative 8. So y equals negative 2. So now that we know our vertex is negative 2, negative 2. So when we plug this into the formula for the vertex form, we have y equals a x minus h squared plus k. So we know the a value is 1 based on this. So we can just erase it because a multiplier of 1 changes nothing. The b value is the h value, I keep saying b. The h value is the same as the x coordinate in your vertex. So we erase the h and put your negative 2. Your k value is the same thing as the y coordinate in your vertex. So we erase the k and put a negative 2. So we can simplify this into something a little bit prettier. So we're going to do it. So we have y equals x minus -2 is the same as x plus 2 squared minus 2. And that's your vertex form. So on the next one, we have this one that we're putting into standard form. So this is in vertex form. We're transitioning it into standard form. So the first thing you have to do is get rid of your parentheses. So we're going to take care of our exponent, and then we'll multiply, and then we'll subtract. So to take care of that exponent, you have to plug it into the area model. You don't have to, but it's a method. So we have x minus 3 times x minus 3. So when we plug that in, we're left with that top left box is where x and x come together. So x times x is x squared. Top right box is where -3 and x come together. So -3 times x is -3x. Bottom left box is where x and -3 come together. X times -3 is -3x. And last but not least, that bottom right box where -3 and -3 come together. And -3 times -3 is +9. So now we've taken care of just the part I highlighted in blue. So we have to bring down the rest. So we have y equals 3. And then in blue, I have my x squared. -3x minus 3x is -6x plus 9. And I still have to bring down the rest. All right, so with PEMDAS, we've taken care of the exponents. Now we can multiply. So we have y equals 3 times x squared, 3x squared. 3 times -6x is -18x. 3 times 9 is 27. And bring down your -7. So now you combine like terms, which are those two on the end, and we're left with 3x squared minus 18x plus 20. And that's your equation in standard form. So don't forget, once you've done your area model to multiply those two binomials, don't forget there are parts of that equation that you have to take care of afterwards. So when we move down here, it says, what form of the equation is that? That is an intercept form. And it says we need to rewrite it, convert it into standard form. So this is where we do the area model again. So we have x minus 1, x plus 3. Top left box, x times x is x squared. Top right box is -1 times x, which is -1x. Bottom left is x times 3, which is a positive 3x. And the last one, is where -1 and positive 3 come together. So -1 times 3 is -3. So in standard form, combine your like terms. And there we are. So now that it's in standard form, we can convert it to vertex form. So remember, label the things you need. It's A and B. So we have A is 1, because there's an implied 1 in front of the x squared. B is 2, and C is -3. So when you plug this in to find your vertex, remember we use x equals -b over 2a to find your h value. X and h in the vertex are the same thing. So when we do this, we're left with x equals negative b, which is 2, over 2 times a, which is 1. So negative 2 divided by positive 2 is negative 1. So now we plug this back in to the original equation. We have y equals x squared plus 2x minus 3. We just solved for x and we got negative 1. When you plug this in to the calculator, or when you work it out, you're going to end up with y equals negative 4. So to write this in vertex form, we now have the two pieces we need. There's your x value, there's your y value. So the vertex is negative 1, negative 4. So when we plug it into the vertex form, we need a and your vertex. So we have y equals, your a value is 1, so we don't have to write it. And then we have x minus negative 1. When you minus a negative, you're actually adding. So I'm going to save a step by using that to rewrite it. So when you have x minus negative 1, you can write it as x plus 1. And then your y value, your k value on the end. So to graph this, we know that the vertex is at negative 1, negative 4. So that's the first dot. We know the a value is 1. So to the left of the vertex, you go up. Let's try this again. So to the right of the vertex, you go up 1. To the left of the vertex, you go up 1. And that is the shape of your parabola. All right, we're going to do one last problem together, and then the next page is your work session. So what form of the equation is this? This is in intercept form. It says to first convert it into standard form. So the first thing I do is I try to make it where the area model is the only thing I have to do. So first distribute this 2 to the first binomial only, because it's only touching the first binomial. And that leaves us with y equals 2x minus 4 times x minus 6. So now I can do the area model. So I have 2x minus 4, x minus 6. So in the top left box, it's where 2x and x come together. 2x times x is 2x squared. Top right box is where negative 4 and x come together. So negative 4 times x is negative 4x. Bottom left is where 2x and negative 6 come together. 2x times negative 6 is negative 12x. And the last box is where negative 4 and negative 6 come together, which has a product of 24. So in standard form, this would be y equals 2x squared. Negative 4x minus 12x is negative 16x plus 24. So the next thing it tells us to do is convert this into vertex form. So you need to identify your a, b, and c. So in this case, a is 2. Remember, a is the number touching the x squared. B is negative 16. And c is 24. So while we're not using C at this point, just get in the habit of labeling it, because in the future we will need it. So now if we're going to put this into vertex form, we have to find our vertex. The way to find your vertex is to find the x value, then plug back in to find the y value. So we have negative b, which is negative 16, over 2 times a, which is 2. So a negative times a negative is a positive 16. 2 times 2 is 4. 16 divided by 4 is 4. So now we can plug it back in to find the y value. We have 2x squared minus 16x plus 24. So we just found out that the x value of the vertex is 4, so we're going to plug in a 4 in both places, and we find out that y equals negative 8. So now that we know our vertex is 4, negative 8, we can plug it back into our formula. So I'm going to do the erase and replace thing again because sometimes it helps, especially when something is different. So we have y equals a x minus h squared plus k. So in this case, the a value is 2. So we're going to erase that a value and put a 2. The h value, remember, is the x value from your ordered pair. Your h value is 4, so I'm going to replace that with a 4. And your k value is the same as your y value, which is that negative 8. So we erase the plus k and put minus 8. And that's in vertex form. So I want you guys to use the next page as a work session. It's basically doing the exact same thing and tying the rest of the unit together. So at the very top, you are simply writing out each form of the equation, just like we did at the very first of this worksheet. And then you are identifying which form each of those are in. You are going from vertex to standard form in these, from standard to vertex in the next set, and then from intercept to standard in the next section. So make sure you get this done. Check your work on Canvas later.